Hello viewers, welcome back to my channel. So today's session is all about the concepts of demand paging, virtual memory and swapping. And exactly I wanted to tell you how these three concepts are interrelated with each other. Now let me begin with the concept of virtual memory, and you cannot separate the term demand paging from virtual memory. Both are interrelated. It's not at all possible to implement virtual memory without demand paging. So let me first introduce virtual memory, then I'll move on to the next term, that is the demand paging. Normally, if you see, the definition in the textbook is given in this manner: virtual memory is a technique that allows the execution of a process that are not completely in memory. What does it mean? The memory is not having the pages of the process. Not all pages of the process are present in the memory, but still it allows the execution of the process. How is it possible? We say with the concept of virtual memory. Virtual memory is simply like an imaginary memory. So with this diagram, you can clearly understand this concept of virtual memory, or we can always say with another word called as logical memory, which is not real. Virtual means not real. So this virtual memory always allows the execution of a process wherein if the process size is greater than the physical memory size. So it looks quite surprising here. The process size itself is more than the size of the physical memory. So how is it possible? It is possible with the help of demand paging. So virtual memory can be implemented using the demand paging. What exactly is happening in this concept is not all pages of the processes are loaded initially in the main memory. Only on demand the pages are brought into the main memory. So you can see with this one example which I have written over here. Look here, let us take, there is one process P1. So here I am just writing this process P1 has got some 5 pages. Which are those? A, B, C, D, E. So these are the 5 pages. Now these pages are brought into the main memory only on demand. See, the reason is not all the pages will be used by the CPU at a time. Only one after the other the CPU tries to access the pages of a process. So here I have shown out of the 5 pages, there are only 3 pages that are present in the main memory initially. So which are those pages? A, C and E. Now what will happen? A is present in frame number 3, C is present in frame number 6, E is present in frame number 9. So only information about these 3 pages which are there in the physical memory is shown in the page table. So you people are now completely aware what exactly the page table holds. It holds the information about what? The frame numbers where these pages are stored in the main memory. So you can check here. So these are the page numbers. What is that? Indexing for a page table is always the page numbers, and then you have the frame number, and here you have another bit of information called as valid or invalid bit. What does valid and invalid bit indicates? Valid bit indicates that the page of that particular process is present in the physical memory. I indicates the page is not available in the physical memory. V indicates, so this is what, since we have placed only 3 pages in the main memory and the frame numbers are 3, 6 and 9 respectively. So you can see here page 0 is present in frame number 3, page 2 is present in frame number 6, page 4 is present in frame number 9. What is page 0? Page 0 is A. What is page 2? Page 2 is C. What is page 4? Page 4 is E. So A, C and E, the only information about these 3 pages are shown in the page table. So the CPU is always what? Accessing the process page by page. Page by page it is accessing the process. Suppose if I have to say that yes, the process size is having 5 pages. Okay, out of those 5 pages, the CPU is trying to access only what? Page A, page C and page E. So only those pages will be brought into the main memory. On demand, the pages are brought into the main memory. That's why we say demand paging. Only on demand you bring the pages into the main memory. In this way only we can afford the complete pages of a particular process whose size is larger than the size of the physical memory. For example, if you see, even at present nowadays we also have laptops with what? Physical memory, that is the RAM capacity as 4 GB, 8 GB, Earlier we were having just with 2 GB RAM, but when we were watching a movie, which is, suppose if your RAM capacity is 2 GB and you are watching a movie of 6 GB, how is it possible? That is why that is possible because the initial part of the movie, which is first loaded into the main memory. So suppose if your RAM capacity is 2 GB, only the first part of the movie, let us take for example the first 15 minutes of the movie is loaded into the main memory. Next 15 minutes gets loaded into the memory. When the memory capacity becomes full, then the first 15 minutes that were initially loaded will be brought out from the memory, and then the next 15 minutes of movie will be loaded into the main memory. This is how, though your physical memory size is lesser than the size of the movie, but still you are able to watch the complete movie. So that is what demand paging, and we say that memory as virtual memory, that is not real. Look here, and also you should know this concept swapping is also interrelated with this virtual memory only. You can see here, this is the physical memory. One example I am just giving. There is one process called process 1. Process 1 is having 3 pages, process 2 is having 4 pages. Any point of time, if at all any other process has to be brought into the memory, swapping takes place. So there is a module called swapper which will swap out the pages of the process. Now here in this, swapper is a one which is going to swap the entire process. That means if there are 3 pages belonging to the process, all the 3 pages are brought into the secondary memory. Swap in is bringing the pages from the secondary memory to the main memory. Now here also, when you are swapping in, you are bringing all the pages of that process. So swapper always what? Swaps the entire process. Remember the difference between swapper and pager. Swapper swaps the entire process, whereas pager will swap only a particular page, swaps the page of a process, Only on demand, if the page has to be brought into the main memory, then we say the module which is carrying out this task as lazy swapper. So hope you people are getting the difference between all these 3 terms: swapper, lazy swapper and pager. So in continuation with the demand paging, there is also one more term associated with it. It is called as pure demand paging. Now what is the difference between demand paging and pure demand paging? First, let me tell you about the demand paging. Demand paging, as I said just in the beginning of my session, this session, once again with an example I'll try to tell you. There is one process, let us assume process 1. Process 1 has got 4 pages. Let us assume 4 pages are there belonging to process 1. So in demand paging, what exactly is happening is, let us first assume that out of all these 4 pages of process 1 in the physical memory, there are only 2 pages that are present, B and C, B and D. Let us assume B and D are present in the physical memory or the main memory. Now the CPU wants to execute an instruction belonging to page C. Page C is not present in the main memory. Then it will be brought into the main memory on demand. So we say that there is a demand paging happening. So C will be brought into the main memory. Similarly, next time CPU wants to execute an instruction belonging to page A, then page A will be brought into the main memory. So in demand paging, initially few pages were already there in the main memory. Few pages which the CPU wants to access were brought into the main memory. But in pure demand paging, not a single page of that process is present in the main memory. You can see here, all these 4 frames of the main memory are empty. The CPU has started executing what? The process P1. So that means now CPU is not finding any page of that process present in the main memory. So now one by one, all the pages has to be brought into the main memory. So that is how we say, when the complete main memory, that is all the frames are empty, and then on demand, one by one all the pages get inside this main memory or get placed inside this main memory, then we say this type of concept as pure demand paging. Not a single page of that process was present in the main memory. And moreover, from where these pages are getting loaded into the main memory, it is from the secondary memory. So if you are having what number of pages, I can show it with this diagram in the secondary memory. So out of how many? All pages are what? Present in the main memory only. Let me show it here: A, B, C, D and E. These 5 pages belong to process P1. So from here, these pages are getting loaded into the main memory. But what I am showing here in this is what? The virtual memory. So this virtual memory can be shown with a diagram in this manner, whereas for the secondary memory, which is hard disk, you are showing all the pages of that process in this manner, and whereas for the main memory you can represent it in this diagram, and also moreover you have to show that how many pages and which pages of that process P1 are loaded into the main memory. And apart from that, you have to show that in the page table in which frames of these physical memory are the pages of those processes shown. Hope you find this session useful. Please like, share and subscribe to my channel. Thank you. Bye bye. Take care.